All right, 3.8, graphing quadratic functions. So we've already found all the parts. Now we're going to go ahead and put this onto a graph. And you might notice really quickly that all of these functions match the functions from the previous notes, where we already found the roots, the axis symmetry, the vertex, and the y-intercept. So I want you to take a minute. You're going to pause this video, go back to 3.7, and just simply copy in all the information for examples 1, 2, and 3 and practice 1, 2, and 3. Go ahead and do that now, and then unpause the video when you're ready to work. All right, so now that we've got all the parts filled out into our graph, we're going to go ahead and just put this on the actual graph itself. So let's start with example 1. All right, first thing I see is these roots. They are at -4 and 2, so I'm just going to actually plot those on the graph. -4 and 2, that's when it crosses the x-axis. That's what a root is. It's a 0 height of the function, right? So like if this is the height, this is when the height is 0. Okay. The axis of symmetry is at x equals -1. I'm going to do that in a different color. Kind of do like a dotted line here at x equals -1. And if you think about it, this is all the points where x is -1. Just kind of shows us a center line of the graph. All right, next up is the vertex. That's at -1, -9. I think that's right there. Yep. So I'm going to even just say V for vertex so you guys know where it's at. All right, and I know that the y-intercept is at -8, and there's -8. So I got quite a bit of information here. Something else that you can know is that every point that shows up on one side of a graph has to show up on the exact same side of the exact same spot on the other side of the graph, because this is the line of symmetry or axis of symmetry. So this point right here means that there's a point also right there. So I'm going to go ahead and plot that in. And if I wanted to get a bunch more points, I'm not saying you have to do this, but if I wanted to get a bunch more points here, I could just plug a bunch of points into the function. Notice, I know what happens when I plug in, for example, if I plug in a -4, I know that I should get a 0. I don't know what should happen if I plug in a -3. See, I didn't plot any points for -3. But I do know -2, -1, 0, and I don't know 1. So something I could do is I could just kind of make a little T-chart. I'm going to do that off to the side here for -3 and +1. So what happens when it's -3? What happens when it's +1? Well, you could do this in your head if you want, or you could actually probably be more successful if you just like write it out. So let's just see, what is f of -3? Well, that would be -3 squared, so that's going to become a positive, don't forget that. And then -8. So that's 9 minus 6 minus 8. Okay, well 9 minus 6 is +3, 3 minus 8 is -5. So that means at -3 it should be at -5. Well, let's just go ahead and put that. -3, we should be down 5. Okay, and remember, I said it has to be symmetrical, right? So if this is 2 points away, then that means this has to be 2 points away. So I can actually go ahead and just graph that right now. It's got to be right there. And if you think about it, that's where x is 1. So if I plug in a 1, I should also get -5. Let's just test that theory really quick. F of 1, well, that would be 1 squared plus 2 times 1 minus 8. 1 plus 2 minus 8. That's like 3 minus 8. Hey, that's -5, just like we said. All right, so we got enough information here to get a pretty accurate sketch of our graph. My graph must be going through all these points. There we go. And also, if I wanted to, I mean, I could find out what happens at, you know, -5, -6, and get, you know, more points along this curve. This is a pretty good amount. On Khan Academy, you're really only going to need to have, like, I think 2 or 3 points. So we got more than enough here to sketch a pretty accurate graph. All right, so now you got this as an example. So I want you to go over practice number 1 and give it a shot. Now here's the deal with practice number 1. I'm going to start you off on this. We have some numbers that are bigger than 10. The last one didn't really have numbers bigger than 10, but now we do, right? The root is 12. The y-intercept is 24. So these are some rather large numbers. And so what that means to me is that we might want to change how we count by. Here, we were counting by 1, so I didn't really have to specify anything. I just assumed that every block was 1. But here, we're going to have to count by more than that. Otherwise, these things will not fit on here. 24 is kind of the biggest number here, or actually -25 is the biggest one. So what we might want to do is count by like, I don't know, maybe 5s so that we know we could fit everything in there. The problem with that is if we count by 5s, it's not gonna fit very well. So what I might do is I might make every 2 blocks equal to 5. So I'll show you what I mean. I'm just gonna write this in really small. That's 5, 10, 15, 20, 25. And I'm gonna go down, so that's -5, -10, -15, -20, -25. So this, by relabeling our graph, we might be able to fit it all in here. And this is definitely a strategy you want to do sometime when you're graphing like on paper, because it won't always fit. So you just kind of adjust it to make it fit whatever you need. So I'm going to make every 2 blocks worth 5, and I think that will work out just fine. All right. I think from here you should be able to do it. Obviously, like numbers like 2 and 7 aren't going to fit perfectly in here. You're just going to kind of estimate where you think it should be. All right, go ahead and give this one a shot, and then check back when you're ready to check your work. All right, after you plug it all in, you should get your roots here at 2 and 12. Again, they're not going to be perfect. You should get a y-intercept up here at 24, so just below 25. Your vertex should be down here at 7, -25. And again, it's just going to be a rough sketch. But just from that information alone, you should be able to get a pretty good idea of what this parabola looks like. And there you go. Hopefully you got something pretty close to that. I also plotted a point over here because I figured, okay, if that's a y-intercept of 24, then that means think about it, the axis of symmetry is at 7, so it's 7 away. So if I went 7 this way, I went to x is 14, should also have a height of 24. So I kind of just like estimated that to help me graph it. And I could have gotten more points, like I said, if I wanted to. I could have made a t-chart and found out, you know, what's happening at, you know, 1, maybe at, we already know that at 2 it's at a 0, but maybe at 3, 4, 5, and so on. You could figure all that out. But I figured there was enough information in this graph, and it was pretty zoomed out that, you know, that's an accurate sketch. Again, on Con, you only need like 2 or 3 points, so we had enough to do this accurately. All right, let's go to example number 2. All right, on this one, I'm seeing that my vertex is at 536. So 36, I'm going to need to have this thing at least at 36. But my x values don't have to be all that crazy, but my y values do. So last time I did every 2 is 5 on both the x and the y, which is something you can do, but you don't have to have your units on the x be the same as your units on the y. So I'm going to keep my units here, just be 1. So, you know, I'm just going to say, hey, you know, that's 1, that's -1. But on the y, to make it fit nicely, I'm going to make them all be, I'm trying to think of a number that would help 11 and 36 show up nicely. And I think if I was to do it by 5s, we could get pretty close to these. So that's what I'm going to do is 5. So every 1 is going to be 5s. So I'm going to zoom in here really quick and say that's 5, 10, 15, 20, 25, 30, 35, 40. That should be all I need. I could go down a little bit too. -5, -10, -15, -20, 25, -30, -35, and -40. Again, see, I'm doing 1s this way and 5s this way. You are allowed to do that. You just have to label your graph accordingly. If you label your graph, you're in good shape. All right, so now let's start plotting some points. Oh, I forgot here that my root is at 11, which is going to put me just off the map, but that's okay. So I know one of my roots is at -1. Let's do this one in black. So one of my roots is right here at -1, and the other one, if I was to extend this just a little bit, is right here at 11. All right, the next thing I'm going to do is the axis of symmetry, and there's actually a mistake here. Remember that these two should match, and I think I copied down the -1 wrong here. So this should actually be +5. And so if I go to 5, I should be able to sketch my axis of symmetry. And I just like to do a dotted line straight up and down. And again, this just helps me know like where the center of the graph should always be. Okay. All right, and my vertex is at 536. So that means I got to go, here's 5, the red line is 5, but if I go up 36, it's going to be like right about there. Okay, and my y-intercept is right here at like 11. Boom. remember, if this is at 11 and it's 5 over here, if I go 5 over this way, this should also be at 11. So I'm going to go ahead and mark that one. This should be right around 11. Okay, and if I wanted to, again, don't really have to. We have enough to get a pretty good sketch here. But I could fill in the blanks here, right? I see what's happening at 0, I see what's happening at 5, but I don't know what's happening at 2, 3, or 1, 2, 3, or 4. So let's just show you how we could kind of fill that in. Go over here, make a t-chart. I got x, this function's name is g of x. So let's just figure out what's happening 1, 2, 3, and 4. So a 1, plug a 1 in. 1 minus 4 is negative 4. Negative 4 squared is 16. Well, that's a negative 16. So negative 16 and positive 36, hey, that's 20. All right, let's do a 2. 2 minus 5, that's negative 3. Negative 3 squared is 9, but that's a negative 9, so 36 minus 9 is 27. All right, plug in a 3. 3 minus 5, that's negative 2. Negative 2 squared is 4, but it's negative out here, so it's negative 4. That's 32. So you can see we're getting some information here. And lastly, plug in a 4. 4 minus 5 is negative 1. Negative 1 squared is 1. It's negative 1, so that should be 35. We can use this information to help fill in our graph a little bit better, right? So 1 is at 20. Well, hey, I know where that is. That's right here. And 2 is at 27, so that's pretty close to about right here. 3 is at 32. It's right about here. And then 4 is right at 35. And remember what I said about that axis of symmetry. It has the exact same points on the other side. So think about it. If the 4 is at 35, so is the 6, because they're both 1 away from that axis of symmetry. So you could kind of just like mirror all these points. So that's also at 35. That's also at 32. That one is also at 27. And this one is also at 20. And now you see you have a pretty accurate graph of this parabola. Again, that's more than you needed to do. I'm just showing you that you can always make a t-chart and figure out where some points are on the graph to help you out. It's a very useful tool when it comes to graphing. Okay, it looks good. Looks like a parabola. It looks a little squished, maybe like this way, than it normally does, and that's because, remember, I made these units 1s and these units 5s, so it does look more squished. Okay, practice number 2. You got some points here that are a little bit off of the 10 mark. You also have a lot of decimals. I don't know, maybe a good one to do here is to just kind of make everyone 2 and kind of estimate. That might be the best bet. So I maybe want to make every x. Maybe you could keep your x's the same, or actually you could even, since you got a 2.5 and 4.5, what I would do here is make your x values be every 1 be 2. So like, or every 2 blocks be 1, sorry. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. And since you need these things to fit in there, you could actually just make this a little bit smaller. So like, we could make it be 2 this way. So I could go like, okay, 2, 4, 6, 8, 10, 12, 14, 16. Same thing this way. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. That should be about all I need. Negative 14 as well. We'll do that. Okay, see, you're totally allowed to do this. You could do these units one way and these units another to help you fit it all in there. And the reason why I chose these, just to be clear, I knew that these are x values, and it'd be nice to get those nice and neat right at the halfway marks, and now I'll be able to do that. And I knew that these are y values, and I wanted them to fit on the graph, and normally this graph only goes up to 10 and down 10. So it just lets me be a little bit more accurate. The trick here is you just have to label these when you do that. Okay, and you have to remember what you labeled these, because now, you know, this isn't 2 anymore. This is now x is 1. So if you count over 2, you have to know, well, that's actually only over 1. I just noticed a slight error here that you need to make note of. This should have been negative 4.5. So make sure you you change that number on your chart if you didn't already. That should be negative 4.5. And now you're ready to go ahead and give this a shot. Unpause the video when you're ready to check your work. Alright, so your graph should look something like this. Remember that was a negative 4.5, it was my bad earlier, I didn't have the positive there. And I actually went ahead and filled in a couple more points of what happens when x is 1 and what happens when x is 2. Gave me a little bit more information. And then I also mirrored those points across the axis of symmetry. And I got a pretty good idea of what this graph looks like. Alright, let's go to the next page. Alright, example 3. It's already in factored form. This one should actually be pretty easy to graph because our roots are pretty easy. It's just negative 5, 5. So I'm not going to bother changing any of the labels here. So negative 5 and positive 5, there's my roots. The axis of symmetry is actually just x equals 0, so it is the y-axis. The vertex is at 0, negative 5, so I'm just going to go down 5. And the y-intercept is the same thing as the vertex. So we got a pretty good idea here. If you wanted to get maybe just one or two more points, you could. Like, let's figure out what's happening at... Actually, I can tell right away something interesting is going to happen here. Because this graph is a 1/5 in front, there's not going to be any neat numbers here. Like if I plug in a 0, that's how I get, think about it, that's how I got negative 5, right? Negative 5 times 5 is negative 25, divided by 5 is 5. So I need to plug in something else that'll be easily divisible by 5. Well, the next thing is negative 5 and 5. That's easily divisible by 5. And you plug that in, you get zeros. So the only other thing that you could plug in here that'd be helpful is 10. So let's just quickly figure out what would f of 10 be, just to give us an idea. I switched the positive and negative around there. So that would be 15, and that would be 5. And if you think about it, you're multiplying by 5 and dividing by 5 here, so really this is just 15. Okay, well, 15 is way off this graph, so that doesn't even really help me. I just know that it's going to, at 10, it's going to be like way up here and way up here. 10 and negative 10 would be the same thing because they're mirrored. So I'm not even going to bother with that. I'm just going to do this. And boom, I got a pretty good sketch there. And like I said, that one only needed 3 points, and that's really all Con needs because that's good enough to get an accurate sketch. I've just been showing you how you could be more accurate if needed to be. All right. This one is pretty crazy, but I would tell you this. The only number that's way off is this 48. So everything else is under 10. So I would just ignore this for your graph, and I would graph everything else. Okay? Leave everything just by ones, graph this perfectly, and ignore that. You just know that your y-intercept is going to be way up here somewhere. Actually, even higher up than that. So just ignore that and focus on these points. Go ahead and give it a shot, and unpause the video when you're ready to check your work. Okay, I went ahead and plotted the vertex here at negative 5, negative 2, the zeros at negative 6, negative 4, draw the axis of symmetry at negative 5, and then I thought, you know what, maybe I get one more point over here, see if I can get a little bit more information. So I plugged in a negative 3. Negative 3 plus 4 is 1, negative 3 plus 6 is 3, so 2 times 1 times 3 is just 6. So that means at negative 3, this thing has a height of 6. If you look, that's 2 over from your axis of symmetry, so this one has to be with a height of 6 as well. So that gave me a little bit more information, and that's it. All right, we are done. See you guys on the next video.